had started empirical formula. Okay, I will do a numerical so that this concept is even more clear to you. So, what is the question? I written down the question. It says in a compound, percentage of carbon is given, percentage of hydrogen is given, percentage of oxygen is given. So, it means the compound contains three elements: carbon, hydrogen, and oxygen. You are supposed to calculate the empirical formula, and what else? Molar mass of the compound is given to you as 64 gram per mole. Also, you have to find out the molecular formula. So, in this question, what are we going to calculate? We are going to calculate both empirical formula and molecular formula. And I have taught you what is percentage composition, and this numerical what we are going to do is when percentage composition is given to us, how are we going to find out the empirical formula? For this type of questions, you will draw table first thing. Okay, what will you? What are the different columns? First column will be my elements. What are the different elements present in my compound? That is carbon, hydrogen, and oxygen. Okay. Second, what will I write? I will write down the percentage compositions. What is the percentage composition of carbon? It is 37.5. Hydrogen it is 12.5. And oxygen it is 50%. Okay. Next thing what we are going to write is the atomic mass of these elements. Okay, respective elements. So, atomic mass of carbon is how much? It is 12, isn't it? Hydrogen is 1, oxygen it is 16. Next column what we are going to do is, we are going to find out the relative number of atoms of each element. And how are we going to do? The percentage composition which is given to you, you have to divide it with its corresponding atomic mass. Okay? So fourth column is relative number of atoms. So what will I do? 37.5 divided by 12. Here what am I going to do? 12.5 divided by 1. And here what I am going to do? 50 divided by 60. This is what I am going to do. I will get a simplest whole number ratio is what I will get. So see, here when you will divide, okay, this value will be approximately 3.125. This will be 12.5. This is again 3.125. Isn't it? These values will come approximately to these numbers. Next column what I am going to write is simplest atomic ratio. Now see, atoms cannot be present in decimal form. They are always present in what? Whole numbers. Isn't it? So what am I going to do? These numbers which I have got, I will divide these numbers with the lowest number and I will get the simplest whole number ratio. Okay? I'll repeat what am I saying. How did I find the relative number of atoms? For that what am I doing? The percentage composition of a particular element is divided by its atomic mass. Okay? I'll get the relative number of atoms. To find out simplest whole number ratio, these values which I have got, all the three values has to be divided with the smallest number. So which is my smallest number? 3.125 is my smallest number. So all the three has to be divided with this number, that is 3.125. What will I get? 3.125 divided by 3.125 will be 1. This will be approximately, I am taking the whole numbers. Okay? Here again I can get 1. So what is my empirical formula actually? This is my table. My empirical formula will be carbon is just my empirical formula. Okay, this is the method how we are going to calculate empirical formula where percentage composition of different elements present in the compound is given to us. Clear? Now, here what else we are going to do? See, the molar mass of the compound is given to you as 64. So, whenever empirical formula is given, you can calculate the empirical mass. What do I mean by empirical mass? Means this is my empirical formula. Here I am going to add the atomic masses of these elements. Okay, I will get the empirical mass. And the molar mass is given to me as 64. When molar mass will be divided by the empirical mass, I will get a factor. That factor is, suppose I am denote that factor by n. So that n, when multiplied with this empirical formula, will give me my molecular formula. I'll do the procedure. I'm rubbing this table down. So see what I am going to do. I need to calculate a factor n. What is this n? N is actually molar mass divided by empirical mass. Okay? Or we can also write it in another form. You can write it as molecular formula is n into your empirical formula. It is the same thing. Okay? So to calculate that n, what am I going to do? Molar mass is 64 gram per mole and empirical mass. This is empirical formula. How will I calculate empirical mass? Just add up the atomic masses of this formula. Carbon is 12, hydrogen is 1, there are 4 hydrogens, oxygen is 16. So 16 plus 4, 20 plus 12 gives me 32. So this n comes exactly, the value of n is coming up to 2. So what is my molecular formula then? 2 into this. Okay, I could also write as CH4O whole 2. This is also a form to write. So molecular formula will be C2H8O2. This is my molecular formula. I hope everyone has understood that I have calculated empirical formula. Once I calculate the empirical formula, what am I going to do? I am going to calculate a factor n. How is this n calculated? Molar mass divided by empirical mass. Okay? Once you got this n, molecular formula is empirical formula into this factor n. Okay? So, this is my empirical formula which I have already calculated. Just multiply it with n factor, you will get your molecular formula. Clear everyone? Now, so this empirical topic, this concept empirical formula topic is over. You will practice more numericals regarding this calculation. Now we will start a new concept, that is equivalent concept. Okay? Okay. So we will start a new concept, that is equivalent concept. We have completed with our mole concept, isn't it? Now see, the problem with mole concept is whenever we are going to solve or going to find out the moles of a particular reactant or product in a chemical equation, you might have seen that first thing I need is I need the balanced equation. Okay? Suppose that they have just give you A plus B is reacting to give the products. In mole concept, you need to know what are the products also. Only then you can calculate using the means in a balanced equation where the stoichiometry as well as the reactant entire equation is known to you, only then you can apply your own concept. Isn't it? What we were doing, if you remember, suppose this is one reaction. In general, I am taking this equation. So here it means that these stoichiometry should be known to me. Only then I can use my whole concept. And what was I doing in the whole concept actually? If you remember, moles of A divided by its stoichiometric coefficient. This will be equal to moles of B divided by its stoichiometric coefficient. Similarly, moles of C by C and moles of B by small. Okay, so I can use this whole concept only when I know the balanced equation. But what is the advantage of this equivalent concept? Here there is no need of a balanced equation. Okay, I can simply write A plus B will react to give me C plus D. Just if I know this much, I can apply my equivalent concept. So this is the advantage of equivalent concept over mole concept. Okay, and here say, how will I apply this concept now in this equation? What does this equivalent concept says? If I know a reaction, not a balanced one, but still I know that A and B is reacting. Okay, there may be some other byproducts also. Okay, that is also not needed when we will apply this equivalent concept. So I just know here there are two reactions, there may be some more reactant also. Okay, but even though if I do not know the entire equation, still I can apply this equivalent concept. And what does this equivalent concept says? That equivalence of A will be equal to equivalence of B will be equal to your equivalence of A equal to equivalence of B is equal to equivalence of C, which will be equal to equivalence of B. This is equivalent concept. Now, here what you don't know is what is this equivalence? For calculating this equivalence, like if you remember how are we calculating moles? How did we calculate moles? We were doing the weight of a particular substance divided by its molecular mass. Isn't it? This is how we calculate moles. How are we going to calculate equivalence? Here what we will do is weight of the substance divided by its equivalent mass. For moles, we will be dividing the weight with molecular mass. Here, for calculating equivalence, we will divide the weight given of the substance with its equivalent mass. Now, you will again ask me how to calculate this equivalent mass. Now, this is what is EM is equivalent mass. How do we define actually? Now, here this equivalent mass should again be, and discuss this in detail. Because for every substance you need to calculate the equivalent mass. Only then you will find out the equivalence, isn't it? So what will I do? First of all, see this equivalent mass means molar mass, that molar mass divided by an n factor. This n factor is not the n factor which we calculated in the previous numerator. This n factor is something else. Okay? This n factor is not the same n factor which we were calculating over there. Remember. Now, what is this n factor? I will teach you in detail. Okay? But you should be knowing that how to calculate equivalence, weight divided by equivalent mass, and how to calculate equivalent mass, molecular mass divided by this n factor. Okay? We will discuss what is this n factor. Now, see what I am doing. I can put this value of equivalent mass over here. In this equation, if you put this formula, what will I get? How am I calculating equivalence? W divided by molecular formula divided by n. Okay. This becomes my what we are going to use when we will solve numericals. Okay? So why I say this equivalent concept is very important because this helps us to solve the numerical even when we do not have a balanced equation. Okay, here I am just going to use this equation. So kindly this is important. Do note it down. That equivalent is actually moles into n factor. Clear? Now see, before we proceed, before we do a numerical, I will tell you how to calculate this n factor. Okay? So let us see how to calculate the n factor. Now, n factor calculation. Okay, now how to calculate this n factor? See, suppose the particular compound or substance, whatever, is given to you that is an acid. Okay, number one, if it is an acid. Now, for acid n factor will be the number of H plus ions which it gives on dissociation. Okay, for acid, what am I saying? How will you calculate the n factor? Number of H plus ions given on dissociation. Okay, like for example HCl. HCl will dissociate to give us how many H plus ions? It will give us 1 H plus and the Cl minus. So for HCl the N factor will be what? N factor will be 1. Okay, similarly if it is acetic acid. Acetic acid will also dissociate to give me 1 H plus. Remember this. Acetic acid is a monobasic acid. Here, though you can see 4 hydrogens are present, but actually only 1 hydrogen dissociates. And which hydrogen dissociates actually? The one which is attached with this oxygen. If I draw the structure of acetic acid, this is the structure of acetic acid. So see, the hydrogen which is attached to carbon, they cannot be dissociated in water. When I will dissolve this in water, how many H pluses? How many H plus will I get? That is my N factor. Which H plus is dissociated by an acid? The one which is linked up with the oxygens. So remember, so here only I will get only one hydrogen. This will dissociate. This becomes acetate ion, that is CH3COO, and this will give me as H plus. Okay? So that is why for acetic acid also I will be getting N factor as 1. Okay? Similarly for H2SO4. Now you can see here H2SO4 is actually a dibasic acid, means it gives 2 H ions in water. Okay, when dissolved in water, it will give me 2 H plus ions. So definitely the N factor will be 2. But you should be knowing that in a reaction, this N factor actually depends what type of chemical reaction is taking place. Means, what I mean is, this is my sulfuric acid. If it dissociates to give me H plus plus HSO4 minus. If suppose the reaction is such that H2SO4 is given only 1 H plus ion, then the N factor will become 1. But if H2SO4 dissociates like this, H2SO4 completely dissociates to give me 2 H plus ions and sulfur ion. In that case, my N factor will become 2. So what does it mean actually? That N factor will depend upon the type of reaction. Okay? So remember, for acid N factor is number of H plus given on dissociation in water, and it also sodium ion, it is 1 plus 1. For 2, it will be plus 2. But remember, n factor is only a number. It does not have any sign. Okay. Similarly, if you would have calculated total negative charge, what is the total negative charge? For this carbonate ion, it is minus 2. And there is only one carbonate. So again, it becomes 2, isn't it? So for this salt, n factor is what? N factor is 2. Similarly, if I take one more salt, if I take Al2SO4 on 3, how is this salt going to dissociate? It will give me 2Al plus 3 plus 3SO4 minus 2. So now look here, what is the total positive charge? 2 into plus 3, that is 6. Negative charge 3 into minus 2, minus 6. Again, factor is only a number. So that is n factor will be 6 for aluminium sulfate. Clear? So this is how we are going to calculate n factor for an acid, base and salt. One more is there, that is how to calculate n factor for an oxidizing or reducing type of agents. Okay? Now how to calculate n factor for an oxidizing agent or reducing agent? Now, for example, if we take an oxidizing agent KMnO4, potassium permanganate. Okay, this is a strong oxidizing agent. Now, this oxidizing agent actually it will see. You know what is an oxidizing agent? The oxidizing agent is one which will oxidize the other substance and itself get reduced. So here for oxidizing agent, n factor will actually be change in oxidation number or oxidation state of that particular compound in one molecule. What am I writing? Change in the oxidation state per molecule is the n factor. So here see, KMnO4, when it goes, when we use KMnO4 for any reaction in acidic medium, remember. How does it changes? It itself gets reduced to +2 state. Here, what is the oxidation state of manganese? Potassium is +1 because it belongs to group 1. Oxygen usually is -2. So, means total here the oxidation state of this oxygen -2 for 1. There are 4, so it becomes -8. Overall, if you sum up, the compound is always neutral, means the summation should be 0. So, what is the oxidation state of manganese? How do we calculate? I will take this manganese as x. So, this is 1 plus x minus 8 is equal to 0. So, what is my x? Oxidation state of manganese is coming up to 8 minus 1. That is 7 plus 7. Okay, this is how I am going to calculate the oxidation state of manganese. So, what is the change in the oxidation state of this manganese? From +7 to +2. The change is how much? Only the change, no sign. So, the change is what? From 7 it is getting reduced to 2. The change is 5. So, the n factor will become 5. Clear? Similarly, KMnO4 in basic medium. Okay, it gives us K2NO4. Now, here what will be the oxidation state? This becomes +2, this becomes again -8, and this is x. So, what is x coming back to? 8 minus 2, that is +6. Isn't it? Here the oxidation state is +6. So, what is my change of oxidation state per molecule? It will be from 7 to 1, that is n factor will be 1. Similarly, for KMnO4, in neutral medium, No. This is how oxalic acid is written. So you can see this is the molecular formula H2C2O4. Okay. What are we going to do is oxalic acid is also an oxidizing agent. Now, oxidizing agent, what does it changes to? It changes to carbon dioxide in a chemical reaction. It will oxidize other compounds and itself will reduce to carbon dioxide. Okay, so here we have to calculate the oxidation state of this carbon, isn't it? Now, what am I saying? What is the oxidation state of this carbon? Hydrogen, it is +5. There are 2, so +2. This I don't know. So it is 2x. Oxygen again -8 is equal to 0. So 2x becomes 8 minus 2, that is 6. Or x is equal to 16. Okay. So here this is a reducing agent. So what is this oxalic acid is a reducing agent. So what will it do? It will reduce other than itself get oxidized, isn't it? So here what is the oxidation state of this carbon? Here if you see oxygen is -2. -2 into 2 -4. So carbon becomes +4. So here see from +3 it is becoming +4. The change is what? The change is 1. But that 1 is actually for one atom. But what did I say? What is N factor? N factor is actually the change in the oxidation state per molecule. Okay? I think I told you before that oxalic acid is an oxidizing agent. I told you by mistake, it is a reducing agent. You can see quite a change in the oxidation state. Okay, from +3, when there is an increase in oxidation state, oxidation is what has taken place. So, if a substance is undergoing oxidation, it means it itself is a reducing agent because it will reduce other substance and itself will get oxidized. Okay, so here what am I saying is, here what will be the N factor? Most of the students saying the change is 1. But remember what am I saying? N factor is change in the oxidation state per molecule. Per molecule means in this molecule you will check how many carbon atoms are there. There are 2 carbon atoms. Isn't it? So for 1 carbon atom the change is 1. For 2 carbon atoms the change will be 2. So the N factor will be 2. Okay, this is a common mistake which students usually do while calculating N factor. Okay, so do remember this is how we are going to calculate our N factor.